Hello, welcome to Level Up Threat Intel with Attack Flow. My name is Mark Haase, and I am the Chief Engineer at the Center for Threat Informed Defense. My background is in software engineering and red teaming. I formerly worked at Microsoft, and prior to that, conducted research and development at DARPA. I'd also like to tell you a bit about our organization. The Center for Threat Informed Defense is a privately funded research and development organization. And importantly, for what we are discussing today, all the work is publicly released. So the Attack Flow project is open source. It's Apache licensed. That means that you can come to our repository, you can leave comments, you can make changes, you can even roll this into commercial product offerings. We just really want to get the work out there and spur adoption throughout the community. So I'll start off by talking about what is Attack Flow. And whenever I'm learning a new technology, I always like to start off with what problem does it solve? And we use this framework throughout the center. We call it PSI, Problem Solution Impact. So we start off with a problem statement and then come up with a proposed solution and then try to figure out what would the impact be if we could produce this solution. And so for Attack Flow, the problem statement has to do with the way that we consume threat intelligence. If we are using a threat-informed defense approach, then we look at adversary behavior more so than indicators of compromise. But we typically look at these behaviors in isolation. We look at them one at a time, and we don't look at how they each relate to each other. So I'll start off by giving you a motivating example. On the left here, we have a news report about a breach at Tesla. Now, this was discovered by external researchers, not by Tesla's incident response team. And so we might, as threat-informed defense people, go through this report and start to identify what adversary behaviors we see in the report. And in fact, in a lot of CTI reporting, if we look at the bottom in the footer, there might even be a table of TTPs that might be mapped to MITRE ATT&CK. Or as you can see here on the right side of the slide, we could visualize this by taking an attack matrix and then shading in the cells that represent the behaviors that were observed. And so I want to dig a little bit more into this idea of looking at behaviors in isolation versus looking at how they relate to each other. So we're going to have a hypothetical situation here. On the left, we've looked at an incident and we've isolated the behaviors that we saw in that incident. So for example, we saw the attacker download tools. That's ingress tool transfer. We saw them execute PowerShell commands, also base64 encoded PowerShell commands. So that's obfuscated files. And then we saw them process dump LSAS memory. So when we look at these behaviors in isolation, some challenges arise. For example, when we say ingress tool transfer, that's kind of a fancy way of saying that they downloaded some binaries. And of course, that happens a million times a day on every network. So is that something that's really useful in terms of detecting or mitigating that behavior as a threat? So as an alternative, if you take a look at the right side, it's the exact same four behaviors, but this time we've assembled them into a sequence. So the ingress tool transfer, that leads to having the obfuscated PowerShell scripts, which then leads to PowerShell execution, which then leads to process dumping. And so what this is showing you is not just the behaviors in isolation, but how they relate to each other. And there's kind of a subtle distinction I want to point out here. This is not just a chronology of events. We're not just saying what order these things happened in. We're actually looking at the dependencies of the events. So for example, you can't execute PowerShell until you have your PowerShell script. And you didn't have the script until you ingressed it. And so at each stage, the adversary is creating the conditions that they need to move on to the next stage in pursuit of their ultimate goal. And one other point to make here is that CTI reports are often not written in this same order. CTI reports are typically written in order of what the author thought was important. So they might actually start with process dumping LSAS because that is the highest and most important thing for you to learn about that incident. But when it comes to understanding the sequence of behaviors, when we're reading that report, we really need to rearrange all the facts in the report in order to put them into the correct sequence. So here's an example of what this same breach might look like if instead of looking at the behaviors in isolation, we looked at it as an attack flow. And this graphic you see here is a screenshot from our Attack Flow Builder tool, which is a web-based tool. Like the rest of the project, it's open source and it's free for you to use. And all of those behaviors show up in the attack flow in these blue boxes with the word action at the top. And so it's showing you not just which behaviors occurred, but also showing you how those behaviors are related to each other. So I'll come back to this in a minute, but this is essentially the goal for where we want to get to with attack flow today. And before I go on, I just want to cover all of the things that are in attack flow as it stands today, because it is a broad project. So there's 4 components that you should be aware of. The first one is the builder tool. It produces the style of visualization that I was just showing you. It looks and works a lot like Visio. It allows you to make flowcharts, but the flowcharts are highly tailored for this attack behavior analysis. And then once you've created your flow inside the builder tool, it is easy to publish and share. And when you publish it, you're publishing it in a machine readable format, which is the next component of the attack flow. So our format is based on STIX 2.1, which is a popular format for exchanging cyber threat intelligence online. STIX itself really focuses on indicators of compromise, and we have extended it with the necessary objects to be able to express the flows and the behaviors. And one of the goals of having a machine readable format is that it brings interoperability between vendors and between different products. So you may have tools that are producing attack flows and other tools that are consuming the attack flows, and they should work seamlessly together. The third component is the flow library. This is a collection of 22 example flows that we have created. These are all based on open source CTI reporting. So you can look at the original reporting, which is cited in the flow, and then compare it to the flow itself. This is a great way to learn. And you could also potentially use this for data mining if you want to see, for example, which pairs of techniques tend to occur together. This would be a great data set to start doing that. And then the fourth component of attack flow, and probably the most important, is the documentation. So we put a lot of effort into making this a really user-friendly and shallow learning curve so that you or anyone that you forward this to can come to the website and they can figure out what attack flow is, who the intended audience is, what the use cases are, and then all the tools that you need to get started are right there on the website. The builder tool is on the website. All of our examples, you can open them up with one click and start working on them. So up to this point, I've talked about what is attack flow. And now I want to talk about the so what of attack flow. And by so what, I mean, why should you use it? Why should you invest time? Why should you take time from your busy day to learn more about attack flow? And we talked a little bit about the machine readable and the ability to share and publish flows, which is important. But for me personally, I think the most important use case here is visualizing the flow. So if we take a look back at this attack flow that we looked at earlier, this is the Tesla flow again. One of the things that jumps out that isn't really clear when you're just reading the news report is that there's actually 3 different attack paths happening here. And I can draw these on. Here's one attack path. This is where the attacker is setting up their infrastructure. This other attack path is where the adversary is exploiting a Kubernetes console and then using that to deploy containers containing crypto mining software. And so one of the things you see when you visualize flows like this is you can see how these different attack paths come together. So the adversary had to do that work up front to set up the infrastructure, but then they also had to do that work on the Tesla network in order to gain access and set up their crypto mining operations. And so this is a really rich way for us to reason and play through what if scenarios. You know, how do we block this attack? How do we prevent something like this from happening in our own organization? We can see a lot of different places here where we could have gotten involved either with detection or mitigating controls to try to block this style of attack. And another thing that I really like about attack flow, if we take a look at this side of the attack, this is actually a hypothetical portion of the attack. So remember I said that the Tesla incident was reported by external researchers, not Tesla's internal incident response. And so those researchers noted that there were some insecure AWS credentials that could have led to further attacks. But one of the things that's not obvious when you're reading that report is that this is just speculation. And so in attack flow, we make it really easy to identify the confidence behind each piece of intelligence that you're reporting and also sourcing where that intelligence came from. And so when you step back and you compare what an attack flow looks like to the original report, one of the things you really notice is that the prose version of an incident contains a lot of ambiguity. There are a lot of orderings of actions that are ambiguous. Sometimes it's not clear when they're talking about mitigations or attempts to cover their tracks, which behaviors they're referring to. And when you go through the process of converting it to a flow, you'll notice that the flow makes it very explicit. It makes it very easy to figure out what happened and exactly what the adversary was doing at each step. And another advantage of attack flow is that once you have this data in this machine readable format, you can generate all sorts of interesting visualizations and do computations on it in novel ways. So this is an example of a visualization that we offer where we take an attack matrix. In this case, it's been shaded in with our detective and mitigating controls. And then we can draw the Tesla flow on top of it. So you can kind of see that left to right progression as the attack progresses. Now, this is just one example out of many. We've also done prototypes of financial modeling using attack flow. And ultimately, we want to see what the world comes up with. This is an open standard. We think there's probably a lot of great ideas out there about how to use attack flow. And it's open for you to experiment with and to write your own code and try to push the whole industry forward. Finally, I'll close with some next steps. So if you are interested in learning more about attack flow, the first thing I would encourage you to do is visit our project website. It is completely self-contained, so everything you need to know is there. If you want to send this on to your coworkers or industry peers, this is a great resource to send them to. It has a very gentle ramp up to go from not knowing anything about attack flow to being really comfortable and proficient with it. Beyond visiting the website, it would also be great to open up one of the existing flows in the library. You can pick out a breach that you already know something about and see how it got translated into an attack flow, or even pick a breach that you've never heard of and really dive into it. The attack flow builder is a great tool for browsing through the flow. It can animate your way through each step of the flow. And it's just a great resource for understanding how adversaries behave. If you really want to take it to the next level, I suggest that you find an open source CTI report and try to build your own flow for it. If you're successful in this, you could even contribute your flow back to our library, open a pull request, and we will merge it in. And then finally, help us spread the word. Like I said before, this is open source. It's available for commercial use as well. And we're really just interested in increasing adoption of attack flow. So you can contact us on our GitHub or at the email address that you see here. And thank you for your time.